Before we get to our talk of the day, a quick run through of something we're working on. Networking is awesome, so how about a week long of it? During the month of March, around March 24th, we are launching Analytics Week, a week long evening affair of meetups, panel discussions, and tons of networking. At this point, we are seeking organizers, sponsors, speakers, and event leads. So if you are interested, please email to sachin@analyticsweek.com. Let me introduce our speaker for the day, Jim and John. Both were introduced to me through our contact in A2C. It was amazing to read what they did. They were doing some neat stuff in data warehousing, and their LinkedIn was amazing to the level that I was really eyeing on the day we will have them as a speaker. So thank you guys, and without further ado, let's call our speakers, Jim and John. So, thank you, sir.
Thank you, very kind of you.
Oh no, it's awesome. Thank you. This thing works.
Oh, really? Yeah, I'll try it. Very clever. So I'm Jim Stagnitto, that's John DiPietro. We'll introduce ourselves to you in just a moment. We're with A2C. I'll just use this. We'll give you a brief introduction, hopefully painless introduction to ourselves and the company we work for. And we wanted to plant some ideas in your minds about the role of big data in data warehousing, and in particular how to model, an agile method for modeling data warehouses that we like, that we evangelize to our clients. We'll talk very briefly about an example of e-commerce example that mixes both structured data and unstructured data, the kind of stuff that you might see in a traditional warehouse and a big data warehouse and how they work together. And we'll give you a brief course, hopefully not, you won't let me drone on too long about it, but give you time to drone on too long about the method for agile dimensional modeling. And we'll do it. So just a real quick, actually we'll do the case reviews up front, so the agenda's been changed just a little bit. John, you want to talk to these slides, or shall I? I can start them if you like.
You can have that one.
So we are a boutique consulting firm. We do everything enterprise data management. We try to really stay into our niche. We try not to stray from our comfort zone there. So we do master data management, data warehousing, and enterprise application integration. We tend to get hired by companies that are in the data business. So we get kind of big, gnarly, large-scale projects for folks like Thomson Reuters and Reed Elsevier and et cetera, IMS Health. John DiPietro, the guy standing up over here, he's our Chief Technology Officer. He'll say a few words in a moment. I run the kind of data warehousing and MDM practice. And I was lucky enough to stumble into some nice writing assignments. So I'm a co-author of an Agile Data Warehousing Design book with a brilliant guy named Lawrence Core. And I'm a contributing author to Kimball and Joe Caserta book called the ETL Toolkit. Maybe we'll give you just a brief overview of what we do. This is, I'll let you drive, John.
There we go.
Space bar to walk through.
Gotcha. All right. Thanks again for having us. It's really good to be up here. And thank you, Vishal, for having us. So, really brief about our company. We have roots in our company that go back to a prior company that started in 1994. It was Alliance Consulting. Can you? Okay.
Let me see if I can put this guy going.
I know the air handlers.
This thing works?
I don't know. What's about this? Speech volume? It seems like it's up.
Or you may just have to project.
Yeah, it should be there. Is this any better now?
Yeah, that's working.
Is it?
Yeah.
Okay. So we had a prior company that we had started back in '94. It was about a $120 million firm with offices in about 8 of the cities, and in 2002 we had sold that to Safeguard Scientific, and then we, a couple of years later, restarted A2C with a very different charter than the first company. Today, as we sit here, our business is really divided into two major groups. We have a traditional staff augmentation group, and then we do a lot of project and solutions-based work, mostly in and around the work that Jim is describing to you, which we call enterprise data management. Okay, but it really involves everything that you see from data governance, master data management, large-scale warehousing, predictive closed-loop analytics, and today, big data. That's obviously, a lot of our clients are very quickly introducing that, and they're coexisting with a lot of the architectures that they currently have in place for their data ecosystem. Okay. So we typically, as I mentioned, we really see ourselves as an alternative to a Big Four consultancy. Many times we are asked to come in and do everything from strategy and roadmap work straight through to implementation. Okay, and many times we do compete with some of the larger firms like an Accenture or CSC, et cetera, but we're certainly a much lower cost alternative. Okay. This is just a sampling of some of the clients that we have, and you see quite a concentration of healthcare. Healthcare is a very big industry for us, as well as financial services, life sciences, pharma, and telecom and MSOs seem to be growing pretty rapidly. And actually, I'm going to be talking about one of them today. Certainly, Comcast is a big client of ours because we're based out of Philadelphia. We do have offices here in Boston, New York. But the case study I'm going to be giving today is actually Rovi. Anybody heard of Rovi by chance? Okay. Again, these are just the typical engagement structures that when we're brought in to do, again, anything from strategy and roadmap formulation all the way through proof of concepts, full life cycle application development, and we even engage in some of the managed services for the systems that we employ. Okay. Enterprise data management, that's Jim and his group and everything in and around data. We do have a business architecture and optimization group, and they actually work hand in hand with Jim's group. I think you're going to see from the methodology that we employ why those two are very important and how they work together, meaning those guys are usually Six Sigma Lean folks that will go in, do a current state analysis, a future state, do the gap, help clients formulate what is the right KPI strategies to really measure performance throughout the organization, and then Jim's group obviously comes in and helps implement that. We have a PMO office that oversees all of our solutions-based work, and we have an application development group that many times, once the foundation is laid for the data, they're building very high-end analytics and visual data visualization apps on top of the data. Okay. Yeah. Thank you.
Yep. Thanks, John. So with everyone's indulgence, let me just ask, if I were to prattle on for about a half hour, is that about right? Is everybody good till about 7:30 or so? Is that cool? All right. And before I start, if you wouldn't mind just raising your hands, data warehouse architects in the room? Yeah, there's one. Good for you, brother. Any modelers? Any just database modelers? Developers, ETL folks? Business analysts? Okay, don't be shy. All right, cool. All right, a good mix. So with your indulgence, I'll try to keep it broad then, right? Since we have a pretty diverse group, and you'll just interrupt me with questions or comments or complaints. The first couple of slides, with your indulgence, we're just going to make a case for the continuing role of dimensional modeling in data warehousing. And what we're saying here is that ultimately information has to be presented to end users, and you could write a book about this, in a form that they can understand. And that means that the data has to be presented in a way that kind of lines up with the way the questions are asked. And questions are asked in a particular way. And questions, there's a structure to the way that we ask questions. Like, here's a representative business question. But if you really were to dissect this question, it's full of interrogatives, like who, what, when, where, why interrogatives about business processes. And because people ask questions this way, a case can be made that the events and transactions we care about should be surrounded by interrogatives when people question them. You should be able to see the business processes that you're measuring and surround them with who, what, when, where, why dimensions, so that they line up well with the way so that the answers can be delivered in a way that lines up with the way that the question is asked. And we'll talk about that in a bit of detail. So the idea that I'm throwing out to the group, and sing out if you disagree, but this isn't terribly controversial, that it probably makes sense to present answers to people in a structure similar to the way that they asked the question in the first place. And so that kind of means that to those of us that are seeped in the dimensional modeling tradition, that answers should be presented in a dimensional form because questions are asked in a dimensional form. And this transcends big data, right? Whether the data is structured, non-structured, semi-structured, fully structured. Dimensional folks like me, who admittedly are seeped in the Kimball-esque tradition, are going to promote the idea that there should be a dimensional presentation of the data in the last, for that last mile. Yes, of course. Kimball. I'm sorry. So this is so second nature to me, I just assume. So there's a guy named Ralph Kimball, who was kind of the father of the Dimensional Data Warehouse. He wrote a whole bunch of books on it. And at this point, that science is so mature that there's a stack of books, and folks who do what I do for a living have a stack of his books on our bookshelf, and there's a kind of a proven design solution to every modeling challenge that you run into. And so part of the question is, what role, if any, does that kind of modeling have in an era that now has traditional data, structured data, and big data commingled, right, in the same giant EMC disk arrays that all of our clients are buying? The brilliant guy that co-wrote, that had all the great ideas in the book I co-wrote, is named Lawrence Core, and his contention that I wholeheartedly agree with is that every dimensional data model looks the same at its core, right? They're all about a business process in the middle that has how many things, like numbers of sales or dollars or durations or units, surrounded by a series of who, what, when, where, why, and how dimensions. So we're going to talk a little bit about the process of designing those things the right way, directly with end users in a way that when they're describing the kind of questions they want answering, they're unwittingly designing their own data warehouse. So the next couple slides would be contentious if we had a room full of big data architects, but luckily for me, we don't. So I'll just plow through them. Here's some suggestions for how traditional data warehousing architectures and how they might look in a big data era. Folks like me that are seeped in the Ralph Kimball tradition, talk about our data warehouse solutions typically have tiers like this is the source data tier. And in the good old days, the source data was always structured. It was things like sales and and page views. And then there's a data movement or integration layer. The ETL people in the room know and live there. Then there was a dimensional data warehouse that had all the atomic data structured in a way that was dimensional, kind of optimized for question answering. And then often we would put some kind of a business intelligence semantic layer over the top that glued all that together and did all the joins and declared the measures as being fully additive or non-additive or semi-additive, so that someone as decidedly non-technical as my mother could create a report by just dragging and dropping things into a report. Companies like Business Objects call that top layer a universe, and Cognos calls that a framework, and et cetera, et cetera. The Kimball architecture, when you extend it to big data, has to deal with the structured data that we know and love, kind of on the right side, but also the unstructured, the new unstructured data that comes in from logs and the logging ports of devices that are monitoring things and clickstream. And so there has to be some mechanism for big data capture. Might be Hadoop, might be Cassandra, might be something like that. And then there has to be some mechanism for big data discovery. That might be MapReduce or Hive or one of these programming languages. But the contention is that let me just go back to that structured data, that unstructured data that's captured in Hadoop has to somehow become structured and find its way back into the dimensional data warehouse so that people can report on it. If your company doesn't use a Kimball style data warehouse and they instead use the Bill Inman or Claudia Imhoff corporate information factory architecture, it's slightly different, right? Bill and Claudia recommend that red thing in the middle is what they call the corporate information factory, which they advocate the creation of a big third normal form data warehouse that captures a normalized representation of all the data anyone would ever need for reporting. Companies like Teradata have made their entire livelihoods out of supplying the big iron for that third normal form data warehouse. But they still put a dimensional tier on top of it. Now, Teradata likes that tier to be virtual wherever possible. And there's still a semantic layer. So a similar architecture, there's just one extra layer of data storage. And when that architecture gets extended for big data, it looks remarkably similar. It's just that now we have to take that unstructured data that's flowing up into big data capture, which is really code word for Hadoop, right? And into big data discovery, which is really code word for MapReduce or some other kind of big data programming language. And it has to become structured and loaded into the third normal form data warehouse at the corporate information factory. So what I'm trying to paint a picture of traditional data warehousing extending gracefully into the big data era. But the truth is that I think we all kind of know that this is such an emerging field that best practices have not yet hardened around that. No one's written the definitive textbooks here. This is just my opinion of how these things might extend. Data Vault, another new technology and an interesting relatively new technology in the U.S. Is similarly stores that atomic level data, but in a form that's ideal for capturing time slice information that changes frequently. And Data Vault architectures also extend in a similar way to accommodate big data. Eventually, it's got to get structured. At least the contention I'm making is, eventually, all that unstructured data has to be mined and structured and then presented in a dimensional form so that people can run reports on it. It might be a symptom of my middle age, but I'm not ready to throw the baby out with the bathwater and abandon all the BI tools that exist and all the data visualization tools that exist. Yeah. Okay. And so on. So there's so many architectures like this. But the common framework that kind of unifies these is you have to have a path to deal with the structured data that we know and love, right, that represents the transactions that run our business. You have to save it in some kind of a persistent repository. If it's a Kimball warehouse, that's the dimensional layer. If it's a corporate information factory, it's that red persistent data store. But either way, you have to store it. And you have to have some kind of a mechanism for dealing with the unstructured data. And then, of course, for our clients that are into data mining and predictive modeling and closed-loop analytics, they mine that structured data then and derive new forms of structured data. So we have clients that load up healthcare claims by the billions, and then they build predictive models in those healthcare claims that identify fraudulent claims or those that are most likely to be incidences of upcoding, things like that. And that insight gets delivered back then into the data warehouse, and that's the closed loop analytics that we do an awful lot of. But fundamentally, no matter which architecture we're talking about, and I freely admit I'm painting a rosier picture of the industry than really exists, but our contention is no matter which of these representations of the industry we talk about, the old-fashioned notion of having a dining room and a kitchen still persist. And what I mean by that is there's still a section of the architecture that real people who want reports are allowed to be exposed to. It's a safe area for them. It's a dining room, they're given a menu, it's all safe, it's all proven. And there's still a back room where mere mortals are not supposed to go. It's dangerous, there are sharp objects there, you can run a report that doesn't make sense. And there's still a pretty clear delineation between that front room and the back room. And what we're trying to say here is the thing that sits on the borderline of that is the dimensional model. And so there's still a need for a dimensional representation of the data. And we're going to talk about how to design that. And I might just take a breath here and see if anyone finds anything I've said controversial. Any critiques yet? Am I still good? All right. We'll briefly talk about one example. Oh, sure. Yeah.
Why is the data unstructured data coming dimensionalized? What do you understand by unstructured semi-structured data and why this is not really a structured data at the end of the day? Because if you are going to put a dimensional model over it, basically you are making a structure out of it, a structured data. You cannot.
I'm sorry, I missed the last one. If I put a dimension model over the top of it, I'm what? Sorry?
So I mean, if the data is not a structure, how can you modelize the dimensions of the data?
Right. Well, see, that's the problem. This data, this unstructured stuff, whether it's logs that we're scraping from a set-top box, right, or it's in some ways it's just raw clickstream data pouring in, it's not really suitable for reporting by end users. It's not in a structure yet. So, right. So people write MapReduce jobs against that, and they essentially derive structure from unstructured data, and that's what this thing's supposed to represent, right? So you save this for posterity. But a big giant pile of weblogs is not informative until someone writes a MapReduce job that figures out a pattern there that's of interest, or sessionizes it, or does something that somehow structures the unstructured data. Now the purists, and I'm not a purist, right? But big data purists would point out that you can do all kinds of interesting things here. We're not challenging that. I mean, people can work their entire careers running MapReduce jobs against big data. The biased point of view that I'm positing is that until it gets structured and until it gets loaded into a dimensional form, the rest of humanity can't use it readily. Now some folks would disagree.
No, I'm more in the dimensional side. It's just I don't understand how I can derive all this structured data and put in the dimensional model.
Yeah.
In our dimensional models.
Yeah.
Difficult to understand.
Well. Yeah, and the interesting thing is that the data scientists in the room and outside of this room are awash in unstructured data, and everyone is creatively writing all kinds of big data jobs against that to try to try to mine out the insights from that. And I don't pretend to have a silver bullet or a glib answer on how best to do that. My contention is simply that once you find that insight, you have wittingly or unwittingly just structured unstructured data, and now you need to put that somewhere. Yep. To those of you who have been fortunate to live lives where we haven't actually seen this mess on the right, I mean, that's what clickstream data looks like. People call it semi-structured because there is a form to it, right? But but it's basically like a big giant dump of every page request from the site. It's typically ordered chronologically. It's not sessionized. And it's just a mess to report on. So a lot of folks like me, and just to be clear, right, what the stuff that's buried in that clickstream data are, apples, oranges, fish, and bicycles, right? I mean, there's page views, there's sales, there's shopping carts being added to and dropped. Lots and lots of business processes are all blended into that, and they have to be extracted and structured. They need to be converted into something that's structured and dimensional in order to be reported on. So people end up structuring them. Believe it or not, that turns into something that might look like this. I mean, this is kind of a typical page view dimensional model in a data warehouse, where each fact represents some user viewing a page, but now it has a nice clean tie to the page itself and the content on the page and the time the page was refreshed and how long the user stayed on the page and how the navigation path they used to get to that page and where they went after that, and everything you could possibly derive about the visitor went to that page. In other words, we've structured the heck out of totally semi-structured data, and this is what clickstream analytics is all about. And not coincidentally, these things represent the who, what, when, where, why, and hows of clickstream data. In fact, to take it one step further, if we looked at a sale event, if we had an e-commerce site where you could browse through products till the cows came home, but there was also a shopping cart where you could throw things in the shopping cart and then buy them, that sale transaction ends up being handled by some kind of an order system or some kind of an ERP, and that sale transaction is fully structured. It carries time dimensions, customer dimensions, product dimensions, et cetera, et cetera, et cetera. So, and it carries measures like unit and price quantities and discount amounts. It's a completely structured transaction that emerged from this semi-structured clickstream. So it needs to somehow end up in what Kimballites like me call a dimensional bus matrix, but what in English you might say is a set of discrete business processes, which are represented by rows here, that could be diced and sliced by a set of dimensions that are common to both the unstructured clickstream data and the structured sale transaction, right? And those dimensions, not surprisingly, are who, what, when, where, why dimensions like time and customer and the web page and the product, etc. So I'm kind of beating a dead horse here, but I'm trying to make a strong case that unstructured data and structured data, but big data and traditional data, ultimately have to end up in structures that we're all kind of familiar with, and that the heavy lift of big data is not just in capturing it, but in figuring out ways to structure it and dimensionalize it. So given that as a rather long-winded prelude, I thought we might just whet your appetites with a brief overview of a process that we like for modeling dimensional data. And it differs from the way I used to do it and folks like me used to do it 10 years ago, where we would march into the CIO's office and we'd ask him or her, how do you measure success? You know, you'd have blue sky sessions on all the KPIs that matter and the ways you want to dice and slice those. So if the hypothetical question Lawrence Core, my co-author, likes to ask is, who was the first data modeler? Was it RK? Was it Ralph Kimball? And he contends it's Rudyard Kipling. Who the heck is Rudyard Kipling? The guy who wrote this little poem that sort of became the heart of every newspaper reporter you've ever met, and every stereotypical investigator in Scotland Yard talks about knowing the who, what, when, where, whys of every situation, and that's how you conduct an investigation, right? And what we contend in our method is that that's also the way you design a data warehouse. You talk to people about a business process and you ask them the who, what, when, where, why questions in a structured way about their business process, and they don't know it, but they're designing their data warehouse for you because their language slots directly into proven design patterns for designing a dimensional data warehouse. Those dimensions make up, not coincidentally, the complete set of things people are going to interrogate the warehouse with. That when we showed you that question, that business question, it too was aligned by who, what, when, wheres, and whys. So, very briefly, history of data warehousing, how do we get to this spot? There are kind of three discrete generations of data warehousing for those of us old enough and crusty enough to remember them all. And one of them was, and by the way, I'm guilty of the sin of building all three types. So in the first generation, we built the big catcher's mitt in the sky. The big catcher's mitt in the sky. The goal of the big catcher's mitt was, don't leave anything behind. We don't know what we're going to do with this data, right? But if we just build a big enough catcher's mitt and structure it in a way that's completely accommodating to anything that the world throws at us, later we'll figure out what we're going to do with it, right? We'll structure it later. So it was really driven by source, supply-driven analysis rather than demand-driven analysis, data-driven. And of course, human beings, being what we are, we swung the pendulum to the opposite extreme, and we started doing report-driven analysis. And right, so we all set aside our catcher's mitts for a minute, and for the next 5 or 6 years, we'd have meetings with our customers, and we'd ask them, bring us all your reports. And if we just got a conference room table big enough, and we dumped all the reports on the table, and we took every row and column heading from every report, and we figured out a way to slot it into a data model, we'd know that we could reproduce every one of those reports. And we'd declare victory and try to get out of town before the business would come up with a new report, was row and column heading, was not there, right? And they always did, something you never got out of town fast enough. And it inevitably led us to the third generation, which I humbly submit is based on business process, right? And theorists are far more articulate than I, but the case can be made that if you can model the processes of an organization thoroughly, you can construct any KPI the business can come up with. But you got to really nail the business process models. So we'll talk about that. We kind of mentioned before that every dimensional model looks the same, right? When dimensions, who dimensions like customer, employee, what dimensions like products and services, causal factors and why, and all the wheres, geographic wheres and URLs, and all the place information, right? that surround a series of facts that we want to dice and slice. And the method we propose for doing that is called BEAM, Business Event Analysis and Modeling. Very briefly, how do you design a data warehouse? Again, I can't help but revert back to the bad old days. In the bad old days, we produce entity relationship diagrams for third normal form, right? Or for dimensional models, the so-called star schema. We do technical architecture diagrams. We do source to target mappings. And this would make the propellers on our hats spin really fast. Like we love, right? Engineers, we love this stuff. But end users can't make any sense of it whatsoever. There's no way you can go to a business leader and hand them one of those artifacts and ask them to validate that you've just captured their business. It makes no sense whatsoever. And the other problem with the way we used to do it was waterfall, right? So we would do big design up front, BDUF, the whole analysis, design, development, test cycle. And somewhere toward the end of that, usually next year sometime, right? You'd load it up with data, and then you would reveal the data to the end users, and they would tell you why it didn't meet their needs, right? And so I think we've all moved to more agile methodologies, right? Those of us that survived that particular hazing ritual have moved to more agile methodologies where you have to deliver quickly, just enough design up front, right? And where the end user has to be involved at every step of the way with that, shorter iterations. And where there's data being delivered at every step of the way, and they're seeing value at every step of the way. Because now, if they don't see value in 60 days, they cut the funding for the whole data warehousing initiative. So one of the things that I think those of us in our profession have been wrestling with is how do you model a data warehouse in an agile fashion? I mean, data warehouses are like the Hoover Dam, and the Hoover Dam does not want to be iterated through, right? You can't experimentally design the Hoover Dam. So what we're contending is that one of the ways you can try to be agile by that is take a business process approach and model one business process at a time. And also we want to take advantage of a certain set of realities. Like one is that the data warehouse modeling space is pretty mature right now. We have design solutions for all the business process scenarios we hit. The thing we really stink at as a profession is collecting unambiguous requirements and slotting those requirements into proven designs. So somehow we take all these great processes and all this fantastic technology, and too often we still deliver data warehouses that don't do what the business ultimately wanted to do. So how to get around it? One way is to do something we call model storming, which is a very interactive session. Data modeling where someone stands up in front of the room with a whiteboard, and an hour and a half later or 2 hours later, you've modeled a subject area directly with the end users. They don't know they've just designed their data warehouse, but they did. And they did it by just having a conversation. The methodology is pretty straightforward. The business intelligence users supply everything they know about their processes, and you give them some focused data profiling results, and what comes out are a few design artifacts that they can understand. With all due respect, even though folks like me love to draw entity relationship diagrams, they just don't communicate to real people. And we break down the barrier between requirements collection and design. What we're saying now is, our contention is that the design process, the design methods are so mature now that when you're collecting requirements, you can be doing design at the same time. It's one body of work. Okay. Collaboration at every step, using structures that they can talk about. I'll spare you the excruciating detail of each of these modeling artifacts, except to say that they're all designed for encouraging interaction directly with end users. They use simple notation, English. They deliver prototypes the next day, hours, not weeks or months. Just in time, just enough design to do the prototype. No more data model reviews, right? The bad old days where where folks like me would stand up a data model in front of a bunch of users and have them throw business questions to see if it broke. We replaced that with actually prototyping it and letting them interrogate the test data that they supply. Okay, so what kind of model? Not this, not the third normal form, not the star, not Snowflake, no abstract models. Apologies to Mark Rothko, but no abstraction. Modeling by example. And I don't know about your users, but our users love spreadsheets. They live and die in spreadsheets. So we model data warehouses now with a spreadsheet. This is an example of a customer orders subject area. And we'll talk about what these columns mean and how these things translate directly into a data model. But suffice to say, take my word on this, but then maybe after the presentation we'll make this deck available to you and some resources available to you. But folks like me walk around now with spreadsheets that have macros in it that if you populate a table like this, it generates the DDL for this database design using the best practices of dimensional modeling. The design process itself is pretty simple. You sit down with a bunch of users and you ask who does what. Now I know this sounds simplistic, but who does what actually is the identification of the first business process that they care about. And if they say something like, well, customers buy products, that's a subject, verb, and object. And those things translate directly. Every one of these words translates into a design artifact for a dimensional data warehouse. We're collecting the design using absolute natural language. We don't talk about facts and dimensions with the users. We just talk about nouns and verbs, and we let them talk about their business processes. The prepositions matter, and we walk through all of the interrogatives, all of the W's, the who, what, when, where, whys, and we ask the questions in a slightly leading way so that we can slot what they're telling us into designs. We use spreadsheet-like models, and we collect example data. We'll talk about that. And there's a certain methodology we follow. We ask the W's in a certain order because it lets us structure the conversation better and make good use of their time. Specifically, when we'll talk about example data, we don't let the users get away with just saying customers order products. We ask them, well, give us some examples of a customer, give us some examples of a product, but not just any example. Give me a typical example. Give me an atypical example. Give me an example where the data is missing. Give me an example where the customer and the product is. Can the same customer order the same product? Of course they can. And we ask questions like that to figure out what makes that customer order's product unique. All right, and give me examples where the granularity of customer and product differs from atomic. In English, what I'm saying is, can groups of customers order a product? Can a customer order a group of products? That kind of question. And what we've actually done is we've collected example data from the users, that is test data we're going to use in the prototype. And we're creating an ETL, an extract, transform, load spec. We want to be able to hand our ETL developers an extremely detailed spec that tells them that this is precisely the data that the end users expect to see in every one of these columns. And on a psychological level, we've forced different tribes in the business who call orders different things and call customers different things to actually sit in the same room. Sometimes we supply pizza, sometimes we don't. And they have to actually come to agreement on examples of what a customer is. And if someone says, well, that's not a customer, they say it right in the room. And we're actually, in dimensional modeling speak, we're conforming the dimensions live with the end users right there. They can't, this model is not complete until they agree on a set of representative example data. Here's some example of thoughtful and example data. Yes, of course.
Traditionally, you mentioned crimes.
Yes.
In situations where, some scenario, you run into pockets of people that have certain intimate knowledge of the areas and tribal knowledge.
Yeah.
You have situations where they're sometimes reticent to give that up because it's job security and protection, and they'd rather hold on to that security.
Yeah. Yeah, we have, and I don't have a I don't have a glib silver bullet answer to that, but usually the project sponsor makes an announcement that these guys from A2C or from your consulting company are going to be doing some agile data warehouse design, and they assign people to show up in that meeting, and they're tasked with doing the model with us, and we have found in general that folks who have a vested interest in defining a customer a certain way will stand up and argue for their definition of customer with the other person. And sometimes they just will never agree. And in that case, we become Switzerland, and we say, fine, you call yours customer and you call yours a prospect, or whatever the vocabulary is, and we allow the two tribal vocabularies to peacefully coexist as different columns in the same.
Usually the rough.
Right. But then we're going to go forth and model it that way. Yeah, I'm sorry, please.
So you said one of these creates a DDL, and I've been wondering since then, what is a DDL and what kind of technology is that built on?
I'm so sorry. Yeah, it's a terrible habit I have. So DDL is, in human speak, is data definition language. It's the code that database developers use to actually build a database.
It's part of SQL.
It is, but it's the part of SQL that actually builds tables and builds indexes and that stuff. It's not the select stuff, it's the create table stuff.
So you're using SQL, not some other technology?
Absolutely, yeah.
Not
yeah.
OLAP database? Not
Not yet, yes. So for this dimensional representation, what we're saying is that if we capture data like this, in a structure like this, in a spreadsheet, there's no ambiguity in how the database design should come from this, to the point where you can actually have a macro-driven spreadsheet, build the tables if you like, or if you still prefer to hand code it, as some of us do, you can go right from this, and you can go to a data modeling tool and design the database. But you're no longer subjecting the end users to the beauty of your data model that they can't understand and they really don't care about, right? That's what I was. Thank you. That's what I was trying to convey. What the end users don't know when you're having this conversation with them is that one of the things we're doing is we're identifying the event type as soon as possible. Now, to those of you, there are a couple folks in the room that were data warehouse architects and modelers. In a dimensional world, there's only 3 types of fact table. A transaction fact, or a discrete event, right? Something like a sale. It happens and it's done. Everything you know about that sale is captured at the moment of the sale. Or an evolving event, like a claim, like an insurance claim that arrives, and then it becomes adjudicated, and then it becomes reviewed, and then maybe it gets adjusted, and then it accumulates intelligence over time. Or a regular recurring event, like a monthly bank statement where you take a monthly snapshot. There's only those 3 kinds of facts in every dimensional data warehouse. And as part of the conversation, actually relatively early in the conversation, you can identify which kind of fact these users are. The business process they're describing will slot into one of these facts in the conversation. And once you know which one of those, once you as the BEAM modeler know which one of these facts it slots into, you can ask some follow-on questions. Like, for example, evolving events have measures that are often durations, because they evolve over time, and people want to know, well, how much time was it between when the order was placed and the shipment went out? And as soon as you hear them talking about durations, you know, oh, I've got an evolving event on my hand, and I can ask follow-up questions that are specific to that fact type.
So it is possible that probably in the first meeting you can not capture all the events, but you still want to confirm the dimensions and all the dimensionality around it?
Yes.
So if in the future you want to capture an event, then what's the strategy around it?
Yeah, so it's a great question. So the idea, we advocate the idea of picking the first event that they tell you. When you ask them, okay, who does what? That first event they give you is probably the one that they care the most about, or the one that's the greatest area of pain they're trying to measure. And we like to model that thoroughly, end to end, that one event. But then once we've done so, as a byproduct of doing that, we've probably modeled a dozen or so dimensions that are going to be common to every other event they tell you about. So if they tell you about an order fact, and it has dimensions like time and product and customer, and then they tell you about a shipment fact, and then tell you about an invoice fact, and then a payment fact, they reuse a lot of the same dimensions over and over again. And so those models go much faster. But we still make them review the example data for each one to see whether this new event that they're telling us about invalidates any of the example data they gave us previously. Yeah, so that's about as agile as we know how to get with the Hoover Dam construction of a data warehouse. We ask them about one business process at a time, and we build it up, and each one of those business processes translates into a subject area, and we build it one subject area at a time. Yep.
Do you see a lot of commonalities between the dimensional models for each of your different clients?
Yep.
So do you rebuild each one from scratch, or can you reuse some elements?
We shamelessly steal industry models that are out there. There's some really brilliant people that have written great books, like Len Silverstone. You folks read any of Len's stuff? I mean, he's the father of the universal data model. Right, and there is such a thing as a universal data model. Absolutely every business and organization in the world follows it. And so we use that as a starting point for all our master data management stuff. And then there's a really bright guy, actually a genius, named Chris Adamson. Anybody seen any of Chris's books? And he actually publishes books that say, like, here's a dimensional model for the healthcare industry. Here's a dimensional model for financial services. Right, and you're right, they're remarkably similar. We do go through the exercise here. Not just because it's academic, because it creates a sense of ownership of the business, of the model they're creating. And it will surface the inevitable differences, right? But underneath it all, you're absolutely right. Every business owner that's absolutely convinced their business is completely different, when the model when the model is complete, it looks remarkably like everybody else's model in that space. I'll spare you the details because I'm running out of time here. But suffice to say that the BEAM modeling process walks through the different interrogatives. So once they tell us that customers order products, well, when do they order them? They order them on an order date. And we add a column to the spreadsheet, right? And we collect example data for this thing called an order date. And we ask them, well, what other persons, what other parties were involved in this? Well, salespeople were involved. Okay, give us some examples of salespeople. And so on, until we've completely described, like a good Sherlock Holmes detective, we've completely described every who, what, when, where, why element of that transaction, which we contend, once you've modeled that and populated that warehouse, you can build any KPI they come up with from. We modeled, I did it again. I'm so sorry. Key performance indicator, which in English means a business measure that someone lives or dies by. Most businesses have a set of a couple dozen of those that they put up on the dashboard, and they give people bonuses based on them. And sorry, I'm so glad you came tonight, because we do the same thing with, once we've modeled the facts, we model the dimensions. It's not enough to just know the customer and their name. The customer itself has a whole series of who, what, when, where, why attributes of their own. So we model the dimensions the same way. And we try to collect everything we could know about a customer, everything we could know about a product. And then lastly, the last step of this, and this is where we involve the ETL people. There are some ETL people in the room. We do some targeted data profiling. We ask the end users, okay, you told us about this event called an order event. What system handles your orders? And then they tell us, well, it's system ABC. We turn to the ETL team and we say we hand them this example data we've just collected, and we have them do data profiling of system ABC. And the data profilers, and the data profiling is the process of using software that automatically interrogates the system's data that you're going to use as the supplier of data to the system, and it identifies things like how often it's null, how many unique values appear, what values appear to change in concert with one another because they're related to each other, et cetera, et cetera. What's the maximum data length? What's the minimum data length? What's the maximum date, minimum date? And what you're able then to see, if you do some targeted data profiling, is how well the source system is actually going to be able to supply the values the business says they want. And you can have a little bit of a reality check the next time you get together with them and show them that we understand you wanted to see these 7 different kinds of values in this column, but the source system doesn't capture it. So the data is not there. And you can start to cross off which data elements are going to be available and not available in the warehouse. And you can have that come to Jesus discussion about whether we should move forward, not move forward, will the subject area still have value, etc. John, I'm going to probably wrap up. Yep, please, yeah.
Last slide.
Yeah. Oops. There, is it this? Yeah.
How much is this credit? How much is individually created for our client?
The process is cookie cutter, but the example data values that they supply, and of course the data profiling results themselves, that's all individual client stuff.
This is all available through some of the references you can make.
Yeah. There's probably some way we can post resources.
Yes, sure.
there's some great books on how data profiling works and how to apply it to this. And the ETL folks in the room know that most of the major ETL tools now have a wonderful data profiling bolt-ons. Informatica bought Evoke software, and they've rebranded it as the Informatica Data Quality, IDQ, is that right? Right. So most organizations that have ETL tools have the ability to do data profiling, even if they're not doing it today. And I don't know. I might cut this a little bit.
I think it should be fine if you'll go over.
Go a few more minutes.
Yeah,
All right.
fine.
Whenever you guys give me a sign if it's time to start. Lastly, we normally like to come up with like a high-level blueprint that mere mortals can understand. That says, in essence, here's your data warehouse on one page. Ralph Kimball calls this the dimensional bus matrix, because Ralph has a knack for making things sound really complicated. But in essence, what it's saying is list all the business processes that we've modeled, right? Indent those that are clearly related to one another, that where one business process is clearly apparent to the next, that there's such a strong dependency that they should be thought of as linked together. And then list all the who, what, when, where dimensions that have been identified as part of that modeling process. And just put a check mark so that we can see that this employee dimension is common with purchase orders and supplier payments and manufacturing process, but not available to these other things. And to the analytic folks in the room, this defines in one page all the dimensionality of the data warehouse, which in English says that these are the kinds of events you're going to be able to dice and slice through. And if you're drilling from this fact to this fact, in other words, if you're asking a question about purchase orders and finding interesting purchase orders that you then want to ask a question about supplier payments on, you can do so for the dimensions that are common to those two rows. But you can't do so for dimensions that are not common to those two rows. All right? So it sort of tells the end user community, this is what you're going to be able to do with your warehouse. These are your drill paths. These are the kind of questions you can ask. Right? And also it tells the project managers, okay, these guys are working on this subject area now. It's going to take them 30 days to do that. It's going to take them 30 days to do this. And they can start to plot out how much it's going to cost, how long it's going to take. It becomes a nice, useful tool for a lot of people for a lot of purposes. Yep.
So do we need to find all the 7 Ws for all the processes, or just like one of the fews, and then so how will that work?
We recommend asking the question about all the 7 Ws for every process. Yeah, including the hard ones like the why, right? Like why things happen. Was it a campaign? Was it a promotion? Was there a horrific weather event? Was there that kind of thing? I'm sorry. Yep.
So I noticed that you renamed the bus matrix structure you're showing here. Kimball has this bus matrix. You renamed it to something else. Is that because people were having a hard time understanding what bus matrix is?
Yeah. Yeah. And I don't know if business process value chain is any better, right?
No, it sounds like it may have better.
But dimensional bus matrix, my mother would not understand what a dimensional bus matrix is. So, and she's the litmus test I like to use. Yeah. But the idea is very simple, right? That these different kinds of events, the reason why, I'm not defending Ralph because we're not attacking, but the reason why the Kimball group named it dimensional bus matrix is they were thinking about the old PCs when you had a bus and you drop cards into the bus, and they wanted us to think about data that way. So if you had a sales fact and it used 4 dimensions, and a campaign fact that reused those 4 dimensions, it's slotting into the bus. The other kind of diagrams we draw are hierarchy types. I'll just fly through this, but there's only a few kinds of hierarchies. Single parent, multi-parent, and fixed level, and ragged. People call them ragged hierarchies, and etc. And happily for us, people far smarter than me have thought about design patterns for all of them. So once you ask a couple leading questions and you know what kind of a hierarchy the sales organization follows, you can just open up the book and pull out the design pattern and model it, and it'll perform well. We like to get our end users, if we can, to graphically depict the hierarchies, and even as primitive as trying to space things so that visually the space between a year and a quarter is bigger than the space between a year, a fiscal week and a year, that it's higher. Because what that lets them do then is start to visualize things. Because every organization has hierarchies that matter. In fact, you can define, I mean, organizations obviously organize, and they organize by hierarchies, and you can draw a line that says this is how we set budgets, or this is how we do forecasts, or this is how we staff the sales organization. It's literally the intersection of different points in a hierarchy line. And business users can see that, they get it, they can correct you when you've got it wrong. And what we know is behind the scenes that this tells the OLAP people, OLAP is a technology for building high-level aggregates in a structure that's really optimized for dicing and slicing fast. That this tells you what kind of aggregates the data warehouse needs. Because if you know how the business is organized, you know what kind of aggregates they need. You know the smallest set of aggregates that will deliver the fastest possible performance, and you know at what level budgets and forecasts are set. I promise I'm wrapping up soon. And lastly, we kind of touched on this, right? No data model review. As much as we love them, I used to work with it. I'll name names. Joe Caserta is the co-author of that book with Ralph Kimball, and this guy's as brilliant a data modeler as there is. No one does dimensional models as good as Joe. But what he liked to do was do these absolutely beautiful, extravagant dimensional models, which he would then put up on the screen to a room full of confused business users that would look at the hieroglyphics and had nothing to say about it. And he would play a game he called Stump the Chump. And Stump the Chump was simply business users would throw questions at him, and he would demonstrate to them how the model answered that question. And they would nod with trust that Joe was right and that the model could actually do what he said it could do. Respectfully, we don't like to do it that way. We'd rather just prototype it. We'd rather take the spreadsheet, turn it into a data warehouse prototype, put their example data in it, let them dice and slice their way through it, and that's how you validate the data model. Recap. Collaborative and agile, right? Approach to both modeling, sourcing, and conformance of dimensions. No more separate requirements in design phase. We advocate combining the two. And validate the model by actually prototyping it and letting the users break it. Letting the users play with it and break it before you pour any concrete and start building hard ETO. This in excruciating detail is described in what my wife assures me is the world's most boring book ever written, but it's out there. And questions, comments, criticisms? Anyone? Yeah.
So talking about the agile, the iterations. So how do you slice those iterative? So is the budget time? So how do you say that this is part of this iteration or this is not, like in your modeling work?
I don't have a good recipe for how to prioritize. We're often lucky where the business users tell us about the most pressing problems they have. They talk about them first, so we model them first. But do we have any agile methodologists in the room? Because you guys could speak to this. You're an agile methodologist, so and I'm not. I impersonate one from data warehousing, but I'm not a Scrum master or that stuff. But the real agile people know how to. They get the business, and you can describe this better than I did. Get the business to describe the value. Yeah. Would you agree that a big part of the agile method is to take the end users gently and firmly by the shoulders, and they have to assign value to things, and they have to decide what functionality they're going to jettison in favor of time or money. It's never painless. Any other questions or comments or critiques?
What's the biggest challenge you see working with doing the Agile Data Design?
The biggest challenge?
Compared to the traditional way of
Well, one challenge is predictably one of it's always going to be on the softer side of things, right? The non-technical stuff. So one is you're indirectly you're saying to the end users, IT is no longer going to be your scapegoat to building the warehouse that you're going to throw mud at. We're actually going to put you in a room, and you're going to model the warehouse with this expediter, right? That we call it a beam modeler. So people are smart. People figure out right away that they're being called into a room to model the warehouse, and if that warehouse is incomplete or doesn't do what their neighbor wants it to do, that they'll be accountable for that. Now, we try to counter that by saying that that it's a process, and failure is good, right? Failure is a step in the journey towards success. But human nature is human nature, and some folks are going to recoil from that. I mean, John, did you want to?
I mean, the only thing I would say is in Agile, what we're doing, a lot of application development, you have the benefit quickly come with a wireframe or a mock-up to show the unique bits and that this is fun, right? So until it's built really ready for use, they can't really show too much.
Yeah. Yeah. The other thing I'd humbly throw out is that I'm not a MapReduce code jockey, right? But I work with folks like that, and folks that know MapReduce really well, or folks that know their way around Cassandra really well, and Hive and Civet, right? To them, this is just so much plumbing, right? Just give me the data. You just throw it all in a Hadoop, in an HDFS structure. Let me at it. Ask me any question you want, and 72 hours, I'll have the answer for you. And some of these guys and women are so good that they can deliver on that promise, but it doesn't scale, right? And it's not repeatable, it's not utility-like. So as much as I respect that heroic ability for a lone programmer to extract wisdom from a giant pile of seemingly semi-structured numbers, it's not an enterprise-class business intelligence system. Yep.
So how does it connect to legacy architecture? So normally, if you end up building a model, so how does that tie up to the legacy, or you are pretty much just rejecting the legacy and then going build a new thing,
Legacy data warehouse or legacy?
Right, legacy data warehouse.
Right. So we often get, I mean, A2, not all consulting companies are the same. We tend to get big, gnarly, ugly data warehouse projects that are often late before we start, right? They're often already over budget before we start. So we're always have to figure out a way to coexist what we're building with what's new. So we're big believers in data abstraction layers or data virtualization layers. Like we will routinely drop a data virtualization layer over the top of the legacy environment and the new environment that we're building. And we'll build our BI. You folks familiar with data abstraction layers or data virtualization, right? These are great new sexy technologies that create a virtual database, right? That maybe is the database that you would have built if the company were brand new. So you structure a virtual database over the top that bridges old world and new. And it lets you change those tires and slowly retire chunks of the old warehouse while you're standing up new subject areas. And then gradually the role of the virtualization layer gets simpler.
And then you map as well that if suppose the new wisdom may be missing some of the legacy pieces which are not sort of, it's a human process.
Yeah.
So if they were sort of miss out on certain reports which used to be KPIs a couple of years back or something.
Yeah.
So how do you pick those things?
Sometimes we have to actually do big massive data conversion efforts from old warehouses into the new. Like we just literally lift the data out of the old, restructure it, drop it into the new structure. Maybe enriched with something that wasn't there before.
Right. Okay.
Yeah. Yes?
Have you seen semantic web technologies gain any traction in this space?
Not a huge amount of traction, but boy, everyone's talking about it, right? Because we work in healthcare a lot, right? And everyone wants, and to the folks that aren't, actually, did you want to describe semantic web, or you want me to take a crack?
I mean, semantic web is like RDF, resource description framework. It's
Yeah.
this whole stack of knowledge modeling technology, originating from Tim Berners-Lee and the World Wide Web Consortium.
If you're familiar with that, like triple stores
Triple
and
stores,
Sparkle.
And Sparkle. So it's people claim it's like create a solution for data integration across many different platforms,
Yes.
but I haven't seen it really take off, and I'm just kind of wondering what your perspective is.
We have all kinds of folks that talk about it, right? There have been fewer sightings of real semantic web implementation, but the promise of it is intoxicating. The promise of it is, right? You take a lot of facts that are unstructured, even just documents, mountains and mountains of documents, right? And you don't even attempt to structure them in any kind of a physical way. Instead, you drop an ontology over the top of it. You know, a real-time interpretation of a vocabulary, all the different synonyms for this word, all the different near synonyms of this word, antonyms, homonyms. And in real time, the user asks questions in a natural language, NLP, natural language processing, and a new kind of query engine, Sparkle, right, which I couldn't even spell Sparkle, right? Goes against the semantic web database and extracts this intelligence in real time. And in the healthcare space, people are experimenting with that because you want to, if you want to be able to pull a lot of data together about a patient and build an intelligent coach that tells a diabetic how to stay healthy, you know, the promise of semantic web technology to do that is massive. Now, this is just one fool's opinion. I don't see it replacing this, but maybe supplementing it. But it seems to be one of those things that where there's a lot of buzz. Someone famously said that, you've maybe heard this, that whatever the new technology is, maybe it's semantic web, it's like romance in high school. You're not getting any, but you think everyone else is, and no one really knows what it is, but you're pretty sure that somebody else is doing it right and you're not. And so semantic web technology is the new, in my own scientific survey, that's the new technology that we're hearing a lot about. We work for a company called Reed Elsevier. It's the #1 publisher of medical text information in the world. They have hundreds of thousands of medical publications and periodicals. And we help build a search engine that goes through that, right? And uses big data technology to index that and make it searchable. But the next logical step would be to drop a semantic web on top of it so that a physician could ask a natural language question and have it intelligently go in and interpret that question and understand the content. And you're right, this is, and people with even bigger ambitions than that are trying to take this and apply it to the entire World Wide Web, right? Tim Berners-Lee and crew.
Yeah, but in natural, still only few companies will be able to use it because it takes the learning system.
Yeah, and I carry some baggage in this regard because I used to work for VerticalNet, and VerticalNet had a spectacular flame out, and they hired every major university ontologist in the country and burned through $100 million. And this was a long time ago. The technology has changed, but you're right. It's very easy to spend an awful lot of money trying to build a perfect ontology. All right, so given that, maybe I'll give you the rest of your evenings to yourselves. And thanks so much for listening. I hope you enjoyed it.